look at hypothesis tests for two proportions. Now that we've done confidence intervals, let's look at hypothesis testing for two proportions. So we need to start with our hypotheses. When we did hypothesis testing with two means, we used mu1 equal to mu2 for our null hypothesis. Now that we're dealing with proportions, we'll use p1 equal to p2. And then our alternative hypothesis is either going to be less than, greater than, not equal to, depending on the situation in the problem. The next step is to calculate the p-value, and we've been using the GeoGebra graphing calculator to do that. When we dealt with just one proportion, we used the z proportion test. For two proportions, we'll use the z proportion 2 test. We'll need to enter in our first sample proportion and sample size, then the second sample proportion and sample size, and then finally the direction of the tail. Less than, greater than, or not equal to. So let's look at some examples. A professor wrote two versions of a test. She wants to test if version 1 was easier by looking at the proportion of the students that passed the exam. We're going to use alpha equal to 0.1. So this table gives us the information about the two versions. The first is the number of people in our sample that passed, and then the second is the size of the sample. So since we're comparing two samples, we know our null hypothesis has to be p1 equal to p2. For our alternative hypothesis, we're checking if the first version was easier. And if it was easier, we would have more people passing. So p1 is greater than p2. Now that we have our hypotheses, we can find our p-value. And for this, we're going to need to use the z proportion 2 test. The first thing we need is information about our first sample. So we had 12 out of 20 pass and a sample size of 20. For our second sample, we had 9 out of 20 pass. And then our tail is greater than. And just a reminder that we do need that greater than symbol in quotation marks. So let's move over to our calculator and type this in. Here's the calculator. We can click the 3 dots, scroll down to statistics, and then down to the z proportion 2 test. Our first sample said that 12 out of 20 passed, with a sample size of 20. The second one said that 9 out of 20 passed, with a sample size of 20. We need to go to the ABCs and symbols to get the quotation marks. And this one was a greater than test. So we get a p-value of 0.171. And so when we compare this p-value of 0.171 to alpha, 0.1, we can see that the p-value is bigger. When the p-value is bigger, we go with H0. That the first version and the second version had about the same percentage of people passing. So in this case, version 1 would not be easier based on these metrics. For my next example, in a sample of 400 people aged 18 to 40, 80 of them said that they smoked tobacco. In a sample of 250 people over the age of 40, 88 of them said they smoked tobacco. So we want to use alpha equal to 0.05 to test the claim that the older people are more likely to smoke tobacco. So let's start with our hypotheses. When we're dealing with two samples, we know our null hypothesis has to be p1 equal to p2. For the alternative, I'm claiming that the older people are more likely to smoke tobacco, so the second percentage should be higher, so p1 is smaller than p2. We now need to use the z proportion 2 test. For the first group, we had 80 out of 400. For my second group, I had 88 out of 250. And my tail is a less than. I can now go over to my graphing calculator. We hit the 3 dots and select the z proportion 2 test. My first group had 80 out of 400. Sample size of 400. The second group was 88 out of 250 with a sample size of 250. I can go over to the ABCs and the symbols to get my quotation marks. And this was a less than test. So we can see this p-value is really small. We have 5 zeros and then an 8. So I didn't write my p-value down here, but we should feel pretty confident that that number is less than 0.05. It was really tiny. And since the p-value is smaller, we know that HA is true. So P1 is smaller than P2. The older generation in this example are more likely to smoke tobacco.